Okay, it's recording right now. So everyone sees my JetBrains solution folder, right? So when we look here, okay, there's stuff which is not so necessary. I will quickly delete it. So this shouldn't be part of it. Okay, so we have the program, which is the start. The first thing we always need is we are using the mass framework, which is available here by the NuGet packages. So if you open that up, you see that we have here the Mars Life Simulations package, right? You can also go directly on the project, click NuGet packages, and you see the installed packages. This NuGet is a package service. And here are different versions. And so if the system is right now continuously in development, so if you find any bugs or something others, we include new features or so, then we will always push new versions, and you have to then to use it to update here the version. Okay, so we have the dependency to our Mars Life Simulations framework. The second thing which you see is here when you look at the project structure. So we have our starter CS, and we have the model in the folder, and we have resources in the folder, and we have a config. And the resources just holds a grid as a CSV file, which is then imported as the environment, right? And here 10 and 0 is just the original values, the starting values of the environment. When you run a program, let me show you that. So if I'm here, when you see here the model, the project folder, you see here we have Wolfe-Sheep Predation like that. And we have here our program CS and the config, right? That's one-to-one the same in the Finder or in any file explorer. And when you create a project, when you run the project, then in the bin folder, the execution files, the class files are created, the bytecode. And also you have here the input files. They have to be copied there to be found, because it is when it is executed, this is the starting folder where it looks like. So to ensure that you have your resources, everything which is required in your execution folder, you need to have these. When you go here to the project, under edit, you can edit the CS project file. And you see that we have here an item group where we have items, the config.json, and everything which is in the resource folder, which are copied to the output directory, right? So whenever you change something, it's automatically copied there. And if you don't have this in here, then your resources are maybe here in your project structure, but not in the bin folder where you require them to be for the execution. So if you create a new folder where you have input files in it, or you rename it or whatever, you have to be sure that you put it in the CS project. All right. Okay. Next thing, let's have a look at our program. It starts with a model description. So what we have to define a model is always a model description and a sim config, a simulation config. The model description defines which parts of the model are included in our model. So you can include layers and agents, and you could also include entities. Entities are also is a meta type, which are also like agents. They have a life cycle and they exist within the simulation, but in comparison to agents, they are not ticked. They don't have their own possibility to act, right? They can just be used. Okay. So what you see is we have a layer, one layer, the grassland layer, and we have 3 different agents. And these agents are added to our model, and we say live on the grassland layer. That means they are somehow bound to one layer. Okay, so this is the way where you say these parts of the model are part of my simulation right now. So if I want to exclude the wolves, then you don't have the wolves in your model anymore. So the runtime system, so the mass runtime system, will not integrate these agent type into your simulation. Next thing is the config. We have a config JSON, which you can find here. The config JSON looks like this. It has different specifications about the simulation. First of all, you can say how many steps or ticks, which means we have a tick. We don't have a continuous simulation, but we have a simulation which is stepwise, distinct from one step to the other, right? So we have 100 steps, and in each step, every agent is capable of doing something. And after these 100 steps, the simulation stops. Then we have an output type. In this case, we just write an output as a CSV file. You could also make an output into a database or in other different types, GeoJSON, whatever. So the system provides various capabilities of doing so. And then you can also specify or make specifications on your output if necessary. And what do we have the symconfig also for is that we can fill our layers and agents with data. We can link them together. So we say we have a layer which is called grassland layer, and we say it requires to have this input file. And for the agents, we could also say it has a file which fills the sheep, or we could say, like in this case, here is an individual mapping. So every sheep gets a value of 4 for this property and a value of 4 for this other property, right? So you have different possibilities. You could also initialize the agent with a file like you did here with the layer, and you can do both and combine it and mix it. You can also put additional parameters. And so we configured all agents that we have with a count, how many we want of them, and their specific values that they get from outside. And why do we separate that, and why don't we put that directly in the model? That's because, or in the code, that's because you want a model to run several times with different parameters. So the simulation is the execution of the model. So the model may stay the same, but you can run different simulations or different scenarios, if you like, with different input variables. So you can change, for instance, the amount, or you can change the grid, or whatever you like. The model itself remains the same. So what we have here is a separation of concerns and an abstraction level. So we can read this file and then work with it. But you could also say, oh, can't I define this config JSON directly in code? Yes, that's also possible. I did it here. So you see here is the same, exactly the same as I had in the config file, just in code. That works as well. The advantage is that you can see what is available. So when you click here, you can see what different options does the system offer me that I can use to configure my scenario, right? And then you see, for instance, okay, we have different output types, and here you see all the output types that are available. Probably not all of them work, but a lot of them should. So I think this code-generated config helps you to get a little bit more familiar with the simulation config itself, but you lose, of course, the possibility to run the model with different configurations when you have it in the code. If you want to do that, then it's better to have the config JSON, and then you just manipulate this file, and you can rerun your model in a different scenario. Okay, that's so far for the overall structure.